In this video, we're going to go over how to solve absolute value equations. Whoa. Now, absolute value equations are often taught with a memorization technique, which you know by now if you've watched my other videos that I am not about memorizing how to do things, but understanding why they work. So we're going to continue with that theme as we rock solving these problems. So how do we solve an equation involving an absolute value? Well, the first thing is remembering that an absolute value symbol, right here, means that number's distance from 0 is, and so you're basically saying, how far is this number from 0? So this reads, x is how far from 0 when it's 5, right? Well, let me say that in a little bit more simple way. The distance that x is from 0 is 5. How about that? So if the distance that x is from 0 is 5, what value or values would x be? Well, let's look at it on a number line perspective. Well, if x is a distance of 5 from 0, it could be 5 this way, but it could also be 5 to the left, right? So it could be 5 either way. So if it's a distance of 5 in both directions, isn't that to the left 5 or to the right 5? It is. So x is equal to 5 or negative 5. And when you check your answer, if you plug 5 in, the distance that 5 is from 0 is 5. The absolute value of negative 5 is also 5. So we have two solutions. So the moral of the story is, once you have the absolute value alone, you undo that absolute value operation by saying the distance that whatever is from 0 is 5. And those numbers would be 5 and negative 5. Awesome problem. Okay, so we'll move on to letter B, and I guess I will jump to this side. We have the absolute value of n plus 12 is equal to 18. Again, the absolute value symbol is an operation, so we want to get it alone. So I'm going to solve this as if you have like x plus 12 equals 18. So we're going to undo addition first. And that makes sense because if the order of operations were occurring forwards here, you'd plug in a number here and take the absolute value, then add 12. So I want to undo adding 12 first. So I subtract 12 from both sides, and we're left with the absolute value of n is equal to 18 minus 12 is 6. Now this reads, and I would read it out loud like I'm doing it when you're doing the problem, the absolute value of n is 6, or the distance that n is from 6, the distance that n is from 0 is 6, right? So this is the distance that n is from 0 is 6. Well, if n is a distance of 6 away from 0, then it's either 6 to the right or 6 to the left, which means n is either equal to negative 6 or 6. And that makes sense. All you got to do is plug in negative 6 and take the absolute value to see it's equal to 6, or plug in 6 and see the absolute value of 6 is 6. Now I know D is right here and C comes before D, but we're going to do D next. To do this problem, you do it very similar to B in that we just want to isolate the absolute value. The reason being, again, is the absolute value is an operation. It's the first operation we would do if plugging in a number, so it's the last operation we do if solving the equation. So I'm going to solve this like it's 4 times a variable minus 2 and add 2 to both sides. And we'll get 4 times the absolute value of x is equal to 24. I'm going to divide both sides by 4. Again, I want to isolate the absolute value. And so I get the absolute value of x is equal to 24 divided by 4 is 6. So we actually get the same exact result as that last problem, but again, I'm going to do the thinking here. If x is a distance from 0, that is 6. So x is a distance of 0, distance from 0 of 6. That means we're either 6 to the right or 6 to the left. So the distance x is from 0 is 6, which means that our answers are x is equal to negative 6 or 6. Beautiful. Last problem, peeps. Here, we have the absolute value already alone, but people often freak out and they add 3 right away. That's an incorrect use of the order of operations. If I were to plug a number into this, the first thing I would do, like if I plugged in 7, let's say, I would subtract 3, and then I would take the absolute value. So we need to undo the absolute value first. So do not add 3. We need to undo the order of operations. Absolute value would be the last thing we would do, so it's the first thing that we undo in this equation. So this means the distance that all of this stuff is from 0 is 15. So the way I think of this is, I think of all of this as just stuff, like the absolute value of stuff. So stuff is 15 away from 0. What does that mean? Well, that means that stuff is 15 to the right or 15 to the left. Okay, well, stuff is x minus 3. So x minus 3 is 15 to the left, or x minus 3 is 15 to the right. That's it. So you get the absolute value alone and you recognize that it's either going to be that number to the right or that number to the left. Now we just solve each equation. I'm going to add 3 to both sides. I get x is equal to negative 12, negative 15 plus 3 being negative 12, or if I add 3 to both sides here, I get x is equal to 18. And if we plug in the answers here, like negative 12, here, we'll check it just for fun. If I plug negative 12 into the original expression, that's negative 15, and the absolute value of negative 15 is 15. Sweet. The moral of the story here, peeps, get the absolute value alone. Then start thinking about what the absolute value means. The distance that x is from 0 is 5, and if you listen to that, gives you everything you need to know to answer it. Go rock some absolute value equation problems, and then watch a later video on some more challenging absolute value equations.